Ohm's law, simply put, states that the current through a conductor is proportional to the voltage or potential difference between 2 points divided by the resistance of the conductor. This is expressed in the equation I equals V over R, and is fundamental to any work having to do with electric currents. This law also applies to currents all the way down to the microscopic scale.
In this video, we will demonstrate Ohm's law at the most basic level, using a wire, battery, resistor, and a voltmeter. We will also show you some more advanced applications for this law, using some fun and exciting clips.
So here we have a simple series parallel circuit with a 12-volt battery source. We have a variable resistor in there so that we can adjust the resistance during testing, and we have 2 parallel resistors up here. The total circuit resistance we measure as 426 ohms, and right now there is about 0 current because this normally open switch has not been closed. So let's go ahead and measure the input voltage applied to the circuit, and we measure it as 12.3 volts DC. And if Ohm's law is right, we can expect to divide 12.3 by the circuit resistance, 426 ohms, and we get 28 milliamps. So let's see. And in fact we do end up with a total circuit current of 28 milliamps. Now if we change the resistance, let's increase the resistance a little bit using that potentiometer. Now we have about 660 ohms. Let's take our voltage, 12.3, and divide by 590 ohms. And we expect to see about 21 milliamps in this case. So let's see. And we get 22, so that's a relatively close approximation.
While Ohm's law is integral in pretty much every application involving electronics, here's one that explicitly uses it. It's probably one that you use every day, at least if you drive a car. Around here, and zoom in, and right there, the gas gauge. Let me explain. This is a schematic of a fuel gauge from HowStuffWorks.com. It's composed of 3 major components: the battery, the sending unit, and the gauge itself. Basically, the battery and voltage regulator provide a steady voltage into the sending unit. The sending unit is composed of 3 other components: a wiper, a resistor, and a float. The float sits on top of the gas in the tank and is connected mechanically to the wiper. When the volume of the gas goes down, the float drops with it, and the wiper moves across the resistor, increasing the total resistance in the circuit. The increased resistance results in a decreased current into the gauge due to Ohm's law. The gauge is made up of 3 components: the heating coil, the bimetallic strip, and the needle on the readout. As the current coming into the gauge decreases, the heating coil loses heat. As the coil cools, the bimetallic strip straightens, pulling the needle into the appropriate position on the readout.